Welcome to Theory of Computation class. In today, I am going to explain the problem of conversion of context-free language to push-down automata. So these problems comes under deterministic PDA, and the last problem, ninth problem, represents that will be only represented in NPDA format. So I already give the procedure for conversion of CFL to PDA. It is a 4-step process. First step, for any language, we should draw a transition diagram. Second step, we should identify the procedure for implementation. So that means that for the representation of each symbol in an alphabet set, we should do some stack operation. So there are 3 stack operations are available: push operation, stop push operation, and pop operation. So it's not necessary to use all these 3 operations. Majorly we are using only push and pop. Depending upon the situation, we can able to implement a stop push operation. And third point is the main important point for construction of transition functions for the given language. It is purely based upon the transition diagram that was drawn at the first step. Then for validation purpose only, we will shift it to the 4th step. Otherwise, the first 3 steps is necessary for this construction. So the first problem is, this is a context-free language which contains only alphabet symbols 0 and 1 in it. So we should construct PDA. Given input is CFL. So we should convert CFL to PDA. First we should write alphabet symbols. So the alphabet symbols are 0, 1, 1, which is given in a language. So steps. At first step, we should draw a transition diagram. For that, we should write the correct input symbols. So here n value is starting from 1 onwards. So the correct input strings are 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 4, 0, 4, 1 like this. So it will be extended. So in the first step, we should draw the diagram. So the first symbol on string is 0, 1. Like finite automata, here for the 2 input symbol, minimum 3 states should be drawn. So first Q0 with the starting symbol 0 and the next symbol is 1. Then it will go to some state. Okay. So I draw the diagram for 0, 1. Next you should just check it at 0, 0, 1, 1. First 0. I go to Q1 state. So if you read 0 at n number of times, you should stay on Q1 state. Then if you read 1, you should go to Q2 state. Then for all the remaining ones, you should stay in Q2 state. So after reading all the input symbols, for example, the input tape contains 0, 0, 1, 1 means what is the next input symbol on tape means it is a blank space. So at the end of the string, blank space will be read. Either we can represent it as an empty string epsilon. So here you can able to represent either epsilon, otherwise blank space. Here I represent epsilon. So if a particular cell with an epsilon symbol is reached, you should go to final state. So this is the transition diagram. And so what is the second step means you should write the procedure. So what is the procedure means? For example, here I am taking the input string as 0, 0, 1, 1. So the tape contains 0, 0, 0, 1, 1, 1. After that, blank space is stored. That means empty string is available. Then the remaining consecutive locations will be stored with empty symbol only. So initially, all the cells should contain epsilon and the input symbols 0, 0, 1, 1 is available. So how can you able to write the procedure means, first if the control head read, before writing the procedure we should write the starting state. So the starting state is Q0 and the initial stack symbol is Z. So I am writing like this. So here it is the stack, it contains Z as the topmost value on stack. And the control head points to the first symbol with an initial starting state as Q0. So this is the procedure. So you should write the procedure first. So if the control head read a symbol 0 with the starting state Q0 and if stack contains Z, what you do means, for all the zeros, for here in the procedures, number of zeros and number of ones are same. So we only push zeros on stack. So if you read 0, you should do push operation. If you read 1, you should do pop operation. So how can we able to construct the procedure means, first initial symbol Z is there. So here 3 zeros are available. So I push those zeros on stack. So now the third 0 is the topmost value on stack. If the control head read 1, first one, you should pop that 0 from the stack. If the control head read the second one, you pop the next 0 from the stack. If the control head read the last one, the last 0 will be popped. Now, if the control head read epsilon symbol, the stack contains Z means you should stop the procedure. In this way, we should write the procedure. Then, third step is an important step, that is transition function. So here, I once again write the same notation here. So initial Q0 and now the stack contains Z as a topmost value in it. So tilde, the starting state is Q0, the current input symbol on tape is 0, the current topmost value on stack is Z. So PDA contains 3 input values and 2 output values. We can easily write the transition function. So how many outflow is there? 1, 2, 3, 4, 5. So for those 5 notations, you should write 5 transition functions. So this PDA contains 5 transition functions minimum. So first you should write it. So Q0, 0. Next one is Q1, 0. So I write the first 2 parameters of input. Then next Q1, 1. And then Q2, 1. And then Q2 epsilon. So these are all the minimum values. And you check the outflow value. If Q0 reads 0, it goes to Q1 state. So I am writing the output as Q1 here. So the output value is 2 values are there. So I only fill the first output value here. Next, if Q1 0 occur, you check the diagram, it stay in same state, so Q1. If Q1 1 is there, it will go to Q2 state. If Q2 1 is available, then it stay in same state. If Q2 epsilon is there, it will go to QF state. So we can easily fill the first parameter. The only complexity is for filling the second parameter. Okay. Now, we already write the concepts. So if any state reads 0, you should do push operation. So I already told that push operation contains 2 values as a second parameter. So here 0 will be read, here also 0 will be read. So I should use push operation for these 3 notations. Okay, if you read 1, you should use pop operation. So here 1 is available, here also 1 is available. So you should use pop operation. So I am writing it. Then Q0, 0 means you should push this value on stack. So already stack contains Z value. Now if you push 0, 0 will come to topmost value on stack. Then what are the two parameter means? Which value is stored on stack? The topmost value and its previous value. So you just check here, the topmost value is 0 and its previous value is Z. So simply I am writing this here. In another way also you can able to fill it. What does it means? If you are doing push operation, you just combine the second and the third parameter value and you write as it is as a second output value. Then, so I am storing 0 here. Now what is you are in current state, you are in Q1 state here. If Q1 with the 0 input, you stay in same state, so Q1 is there. So now you are reading the second value, the topmost value is 0. So this is the stack topmost value. So I am writing here, this is the stack value, this is your tape value, this is your current state, and it is your output state and your operation, stack operation. So if you are reading 0, second symbol 0 with the input state Q1, the stack contains 0 only. I already write the push operation. So you just combine the second and third value. So 2, 0. So you push the second 0 here. Now it is the topmost value on stack. You just check the output state. You are in same state Q1. So the third value is also Q1 0. Q1 0 means the outflow should stay in Q1 state and you should push the third value on stack. So immediately store the third value on stack. Now we are in which state? Q1 state. This is the topmost value on stack. If Q1 read 1, what you write it? You assume that if 1 will be read by any of the state, you should use pop operation. So Q1 now read 1 value, then what is your topmost value on stack? It is 0. What should we do? We should use pop operation. Pop means only one value should be written as the second parameter. That parameter is epsilon. Okay. So epsilon, if you pop this value, 0 will be eliminated and this will be the immediate topmost value on stack. And your current state is Q2. Then, what is the next number? 1. So, if Q2 read 1, you should stay in same state. I already write it. What is the topmost value on stack? It is only 0. So, Q2 read 1 means you should use pop operation. Pop means we should use epsilon. So, if you pop this value, the topmost value is 0. You are in the same state. So, Q2 read 1 value. Stack topmost value is 0. So if you read 1, you should use pop operation. So the number is popped. You are in same state. So now Q2 read an empty symbol on tape and stack contains Z as the topmost value. So if Q2 read epsilon and stack contains the topmost value means you can able to stop the procedure. Okay, so the tape is epsilon. So if Q2 read epsilon, you can able to go to final state. So this is accept state. Okay, so you can go to the accept state in two manner. Either you can go to final state, otherwise your stack should be empty. Here two conditions are satisfied. Here my stack is empty with the input symbols, only it contains initial stack symbol in it, and also that particular push on automata will go to final state. So these two will be occurred. So this is the transition function. Then how can we check it means? This is the fourth point, validation. For validation, I will take the value 0011. Then your initial state is Q0. You want to check 0011. So this should be stored in the tape. So at last it should contain epsilon and your initial value is Z0. So this is the instantaneous description in which the first parameter, first value of second parameter and first value of third parameter should be checked in a given set of transition functions. So I give the number for all these transition functions. So Q0, 0, Z0 means you should go to Q1 state. So I am writing Q1 state here. The remaining symbols are 0, 1, 1, epsilon. Then push means what you should write? The 0 will be pushed to the third parameter. So 0 Z. Now the first value is Q1, first value is 0, second, third parameter first value is 0. So you just check it out, Q1 0 0. This is the second function. What you do? You stay in same state Q1. What are the remaining values? 1 1 epsilon. What should you write? You should write 0 0. So I am writing 0 0. So instead of single 0 I am writing double 0. The remaining value is Z on stack. So 3 values are in stack. Now we should refer Q1 1 0. So where Q1 1 0 is there, this is the third function. The state will go to Q2 state. The remaining symbols are 1 epsilon. So what you should do? Pop. So if you pop the topmost value, the remaining symbols are 0 Z. Now you should refer Q2 1 0. So Q2 1 0 is third notation. The same thing, you should stay in Q2 state. The remaining symbol is epsilon. If you pop that value, only Z is there. Now you check Q2 epsilon Z. So it will go to accept state. So this is the correct input. So if you want to check the wrong input, you can able to use the same procedure for checking it, but there is no condition for that output is there. So this is the way we can able to construct a push-down automata. So we'll further discuss the problems of conversion of CFL to PDA in next session. Thank you.